Hello, 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 hello. And we're going to continue to transpile the minicast into C programming language. So here's what we have achieved yesterday. We do have a simple example which does the Fibonacci numbers. Which prints the Fibonacci number 10. Right now though, it is all, except for the Fibonacci function itself, it is all printed using a single native expression, and we want to split this into like print string, print int, print string, so that we actually are not going to use the printf function in the cast. We're instead going to do these things, right? So this is the code that we want this code to be instead. So we want to be able to print string, and we want to be able to print int 32. And what this means is that we actually, because of the strings, we actually will need a little bit of runtime in C to specify what a string is, because we don't want the strings in C to be just the strings in minicast to just be the pointers. We want them to be the pointers plus length. Right? Well, in fact, I guess that we would have to do something similar to what Rust does. But that's not how I have my standard library currently. One thing that we maybe like not necessarily need is the mutable strings, but there should be a difference between the owned and a reference to a string, I guess, right? So that we know who should deallocate the memory. So the way Rust does it is that you have the str type, which if you get because this is unsize type, you get the reference, and this becomes like a fat pointer, right? But is that what we want? Or do we say string view instead? Or like string slice, right? And that would be the not owned one, and then string itself is the owned one, right? That way we have the actual difference. Right? The internal representation is the same though. It is only a matter of who deletes the data. How are they doing strings in a C++, by the way? Because they do have the string slices these days, right? String view C++. They call it string view, I'm pretty sure, right? Basic string view describes an object that can refer to a constant contiguous sequence of chars with the first element of the sequence at position 0 for a basic string view str pointers, iterators, and references to the elements of str are invalidated when the operation invalidates a pointer in the range. Bum, 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 bum. Let's start with the simple one where we have the strings. And I guess we would we could start simple where every string is owned, right? It just means that when I would do the substring, for example, it would create a new owned thing, which is actually what's happening right now when we do convert to JavaScript, right? But then eventually we need to add a special type, which would be the string view, I suppose. But let's do the owned ones for now, sure. Sure. Wait, if they are owned, how do we do the constant strings, right? How do we do the constant string? Because the add member should not be deleted ever. Right? It means that I create this thing over here, actually. When we see the literals, the string literal, we actually allocate it. Or else this should be the reference type. Yeah, this is difficult actually to do correctly immediately. Let's call it string view then after all. Maybe we only have string views for now. We're not transpiling Kast to minicast yet. So we'll have the string views only. Okay, so the issue is that I need to be able to specify what a string view is. Right? I do want to have this in this runtime probably. This includes the other things. Which we are going to comment out for now. And we're going to say right here that we have the string view, and it's going to be a type struct. Right? It's going to be a struct with two fields, the content and well, I mean, should it be like that actually? Maybe it should. content and length is what we need, which means that I should be able to just say as dot content here and as dot length. So the length would be the size t. And the content would be also something. I feel like what we need for types, though, is to be able to specify the native types. That's what we need. Because right now I don't have the ability to do that. So I feel like this should be a native size t, like this. And the content, this also would be a native type, char star, right? Like this, maybe. I should say type, so that it knows that it's a type. So whenever I'm parsing a type, the types should be able to be native types. Right? And I just dump them as is. Yep. I think that sounds good. That's all we do in the runtime. We just specify the types, which means that it's not a real runtime yet. But yeah. Maybe I call this C string, right? And I will call the C string is a type native char star, right? Like this. Which means that when I compile the C, I need to have the path, and I also need the runtime, right? And the runtime would be source mini backend C runtime mks, right? Okay, so now it says that we expected a type, but we got a native size t, which is not something that is expected here. Right now, so let's do the mini compiler. And over here, we should be able to have types which are native types. And these are just like strings. And so when I write the native type, we literally just write this thing as is, and that's all. When I say type name as identifier, what do we want here? What are we going to have to do here? Okay, and when I transpile to C, when we have a type which is a native, right? The AST type should be native too. So in the JavaScript AST, the type should also be native. Native. I mean, I call it raw in other places, right? Let's copy transpiling to the Holy See. Yep. Transpiling to the Holy See. We're going to have holy segfaults very soon. Trust. We're almost there. Maybe I should not call it native then. I should call it raw. I have so far done the Fibonacci, but now I'm trying to like do this a little bit differently, where instead of printf, we like split the printf because I don't want the printf, I think, in the minicast. So I'm making the strings right now, and we will have like string views, I suppose, and stuff, as our string literals are going to be actually still a pair of content, pointer, and the length. That's what I'm working on right now. To see Thano. Hello, hello. Yes, to see. Expected type got natives. Okay, hold on a second. We need to have in the mini compiler, if I have a parse type over here, we need to say that if rule name is native, then then raw is root is the helpers expect single child with no name, and then we also want to expect string. Are you working on Kast while doing job? No, I'm not doing my job at the moment. Hello, tired beaver. I think that's literally what we do. but I need the AST helpers to also have the string, similar to how I expect identifier, and to expect a string. This will give me the string, which is the contents of the string, right? So if it's a token, shape is a string, have the contents, then we the contents. Otherwise, we expected a string token. All right, expected type string view got string over here, right? Okay, that is because we are actually, yeah, when I'm compiling the string literals, they are inferred to be of type strings, but we want string views. And I guess we will need to do changes in Kast for this to work too, right? Do I actually have like the string? Yeah, the string right now is kind of like the primitive one. Well, I mean, in some backends, the string view and string is going to be the same still, I think. The literal is still a string. Maybe I do have like the types, which is going to be a string and a string view. We will differentiate between the two here. Right? So when we have a string literal, all of these should be string views. String literal has the string view type, right? Is that what I want? And then when I compile to C, when I convert the type, we are going to convert the string view. We're not going to convert the string yet. Well, I mean, string view is still going to be named string view because this is specified in the runtime, right? I guess string is also going to be specified in the runtime, so we will do string and string view there. Right? But the difference is how we have the literal, right? So when we calculate literal, this returns the literal. But in C, this is not going to be a literal anymore, right? String views in Kast, yes. In minicast specifically right now. Okay, so the question is, let's go to over here. What we want is to do something like this. We're going to have the string view in C, which is going to have a char contents and size t length, right? That's what we have. And what we want, let's say that I have a function void print string, which is going to have the s, which is string view, right? Yeah, and over here, so that's what we want. We want f right, the std out, the as content, size of r as length, right? So then we want to print string. And over here we want this literal hello world, right? But we don't do this. We say instead contents is hello world. And length is whatever. So this is going to be calculated in Kast, right? Expected expression, but this is not an expression. So how do you make this an expression? You cannot, right? You must do this. Can you not have inline constructors like this? C-lang, initializer, use initializer lists, is that what they called? In the function args, right? Something like that. You can achieve using compound literals. Oh, you need to do like this, right? Okay. You need to specify the type and then do that. C compound literals. Since C99. Constructed and named object of the specified type, right? So we just have the type and then this stuff. Yes, makes sense. But the empty one is only since C23. Interesting. Right? So is C23 the C where they introduced the zero-sized types? Or something? So we want over here the string view, like that, right? There we go. That's how we do the string literals. Who's writing C23 right now? Are you guys all stuck in C99, like people who are stuck in Java, even although there's like Java like 30 already released or something? Is C having like the same problem as Java? You write horrendous OCaml?
Hello, Nigel Ithro.
Nigel, hello. So this is how we convert this thing. By the way, and can we do this in the in over here, like const string view hello world? I'm just wondering if I can use the same syntax over here. Does this work? Seems like it does. Okay, nice. Oh, buffer. So when we convert the, so they call it the compound literal, right? Let's call it the compound literal, right? We have the expression, which is not just literal, right? But compound literal, right? Which is going to be the type and the initializer list. And what's the initializer list, by the way? List of initializers suitable for initialization of an object, right? It does not necessarily have like the fields, right? Yeah, or here, yeah, just like I said, say J++. Oh, wait, you don't need to specify the thing. How does this work? If you, so like over here, I specify the dot contents. Can I just do that? Wait, this works? Wait, so over here we can have both unnamed and named fields. This is like just like Kast. If in case you're not specifying the names, it must be like the same order as in the definition, I'm assuming, right? Yeah. I'm just trying to understand what they like call here initialization of an object. Yeah, you can use it for like arrays, colors, and struct initialization. For structs and unions. So you initialize the union actually like in the same way, right? Where you specify the dot which variant and the value. And what is this 0.a? What? Wait, this is complicated. You can do like the nested initialization, right? Yeah, and also you have these like inline struct types too, and it's like this is an array of structs, right? So the first A is one. Parsing C is pain in the ass. Yeah, well, thankfully we don't need to. I'm wondering why they do this. This is making it not a simple language anymore, is it not? Like, why do they even allow it? Just require the type alias to be created first. Wouldn't that make it a much simpler language? You don't know what language is simple anymore? Right. It's Kast. Um. Okay. So okay, so it depends on what I want to generate. Let's just have that we generate the fields always with by the name. How about that? Right. So we have the field initializer, right? And field initializer is like we have the name and we have the value, which is expression, right? And this is going to be a list of initializers. I'm wondering why they call it compound literal. This is like not a literal. This is the full expression and stuff, right? And what's the evaluation order here too? If you use actually some complex expressions here, do they specify the evaluation order, or is it not specified, like in the function arguments? Actually, I never printed the literal. I'm just realizing when I'm printing the expression over here. Compound literal. Hello, Raymarch. I think in C++17 they had to specify some of it because it was used as a trick to unroll variadic templates. Right. And since you're writing OCaml, by the way, Tired Beaver, I'm wondering if you have hit that bug, that issue in OCaml, where in OCaml the evaluation order of the arguments is also not specified. And I was, for some reason, assuming that the language is sane, and I was like relying on it in some places, and I had bugs because of it. Because I did not read the manual before writing OCaml. Yeah, the order of arguments, they can be evaluated in different order. And also when you have like the same compound literal syntax in OCaml, right? When you initialize the object, right? You have the object, you know, like field one is like this, and field 2 is this. This also is the unspecified order. I'm not sure if labeled arguments are also calculated in order. You need to actually like construct the variable first, the local variable, and then pass it to the function, I think, if you want to like not have bugs. You looked at this one, right? I don't know. Well, I'm doing C, not C++, right? Speaking about left to right and right to left, did you know that the order of evaluation in Rust is also sometimes weird? I've seen this thing earlier today. Let me look it up somewhere. If I can find it, maybe this one. So let me see the example, right? Here's the example. So did you know that this in Rust evaluates differently? So you have the function foo, which takes a reference to an integer, basically, and another integer, right? And you basically mutate it by saying plus equal. But on the left-hand side, you calculate what you mutate by printing it first, right? So this way we know what evaluates first, the reference that we are going to mutate or the value that we're going to add, right? And the answer is that it's different for this code and this code, even although these two things look exactly the same. Did you know this, Raymarch? In C++, it's the same. It's unspecified but not undefined behavior. Right. Yeah. Well, the fact that it's the same in C++ doesn't mean that like it's not weird in Rust, right? So basically, in one case, it evaluates left to right, and in another one, it's right to left, because it's based on the actual types. So if the type is like known and not generic, then it's going to be left to right, and otherwise it's going to be right to left. So it's based on the type. Compound literal. Type Did they call it fields? I already forgot. Yes. Okay, so we are going to write the opening. We're going to write the closing. We're going to write this. We're going to write that. We're going to print type. Go over the fields. Split them with commas. Do I want to have like a new line here and increase indentation and then decrease indentation? Maybe. Then we can have the trailing commas, I think, right? Can we have trailing commas in C over here? Yes. Okay, and then it means that over here, when we calculate the string literal, we are going to actually convert it to a compound literal, and I'm going to return it, right? Return. Expression is compound literal. We have type, which is named string view. Yesterday you had a WGPU race condition. Yesterday I sec faulted the C compiler. If you have not been here when it happened. The clang specifically. GCC was okay. Next time you'll come in stronger. Yeah. Let's see. So we have the field. We have the field content, and we'll have the field length. Name is contents. Value is, and this value over here is going to be the literal string, the C literal, right? Literal string S. Let's call it S. Expect that WGP is not doing ref counting of textures correctly. Nice. Have you reported it or something? Should I have reported the clang bug? That's literally what they told me in the seg fault after the seg fault happened, but I didn't. Length is we have the length field, and the value is literal, which is an integer. integer literal, and this is going to be string length of s. If it's a C issue report, if a C++ issue, let the existing run. The example is very simple. I was actually like, you know how I was pretty sure that C does not have the zero size types, but apparently they do. And if you have like struct ZST, you know, type def struct ZST like this, right? And then you can have basically ZST, and you do this, you know. And you can also like printf percent the size of ZST. Right, it's going to print 0. Yeah, actually have the zero size types apparently. Maybe it's in the like latest like C23 or something. I'm not sure yet. And then if you have like the array of zero size types and you initialize it like this, you have like two arrays. There we go. My language server is already dead, and then if I do this, then it's going to be the segmentation fault here. Should probably report this. You think it has not been reported yet? I mean, also, it's wait, hold on. It also says that there's too many braces around this color initializer. I feel like maybe it's something is weird happening here, right? We also have a warning before this. Because it thinks it's a scalar initializer. Right? Empty struct array initializer. Compiler crashes when C buffer contains an array of empty structs. Is that the one? I mean, this is an array of empty structs. It's not like the... But maybe this is the related issue. And maybe it has been fixed on March 11. But this is C buffer specifically, so probably not. I don't know. Like, looking up this issue is work. If there is already the existing report, though. Is the compiler panicking or the compiled code panicking? It's just compiling. Yeah, no. It's not the compiled code. There's no panics in C, right? It's by the way, it's in the parser, it seems. It's in the parse AST. It's the parser, not even the compiler. Right? Content length. Okay. Is that it? String is not ident. Where? This over here. What happens if you put only the zero size type in a struct also? Is another question. Type def contains ZST. Right, struct which contains ZST inner. Right. Let's say contains ZST foo. So can I say like dot inner is this? Right, this works, by the way. And size of contains ZST is going to be also 0, right? But I have two inners, inner 2. Right? It's still 0 with with two 0 size types inside, right? And what if I print? Can you print a pointer in the printf? Or do you need to convert it to an integer first? Printf, print pointer. %p, right? Printf, %p, inner is %p, inner 2 is %p, void star, reference to foo inner, and void star, reference to foo inner 2, right? So like, as I understand, the zero size types were not supported previously because you wanted the pointers to be different, but that is no longer the case because we literally have the pointer, which is the same, right? Which makes sense, I suppose. Right? But, yeah. C23, zero sized type. Like, they actually edited it? Empty structure declarations are generally forbidden or have implementation defined behavior, often violating the strict conformance which requires a non-zero size, right? So it's like the specific, it's like specific to the compilers that I'm using, but it's the same in GCC. It still is 0, right? And the pointer is the same. Pattern match is non-exhaustive over here. The string view, resolve type aliases, right? If we have the string view, there should be string view. I should have like, I don't know. I'm too lazy to do it, but I'm really lacking the exhaustiveness checking at compile time right now. At least we have it at runtime. short type name, of course. Segfault, maybe I should also filter here. Or do they have like the policy where I can just like introduce the issue if there is like already the thing? How long should I spend searching for the thing? Expected string view, struct got string view. Oh no, hold on. Expected type string view got string view. That is not right. Um, why is that? It's because we have the type check. In the compiler, right? Type check over here. Type check impl. I mean, if I have two string views, oh, because one of them is like named. Yeah, that's right. Because then to resolve the type aliases. Right. Yeah. Yeah, because string view is actually supposed to be not specified. Like, because I specified in minicast itself. Right? Like, this should. Maybe it's the job of the resolve type aliases, kind of, where we still like have it as a struct, but for the sake of type checking. Like, what's the less cursed way to do this? Because it's a special type, the string view. Right, we can say the name, right? And I basically can say that if name is equal you know, if name is equal to string view, we don't need to look it up, basically, right? We are assuming that it exists, and it's like the built-in string view then, right? And we will do the same for a string, right? So this means that we can like define for the primitive. Maybe it should be like for all of the primitives. I don't know. Is this cursed? When I'm doing the resolving of the type aliases? Yeah, because like I need to. Yes, I actually no. This is cursed because I will not be able to look up the fields of it actually. Right? Because it says that string view now doesn't have fields. That's right. because this is a primitive type. So like when I look up the field, I need this to be an actual struct. I feel like this is not the correct way. So it's probably like in the type checking, type check, right? Where we don't only resolve type aliases, right? But like we do the extra stuff where we treat like the special types, right? So maybe it actually is this way, right? But it should be, you know, if some special, right? If treat special, and it should be like the other way then too, right? Where like if it's a string, then this should look up the named one actually. Yes. So like we basically need to convert them to the same thing. Always. Right? Well, if I convert them always to the same thing, then it doesn't like really matter. I feel like we're going to resolve this to a struct if it exists, and if it doesn't exist, then it's going to be the native. Yeah, I think that's the way to do it, maybe, because it's depending on the backend. So string view is actually an alias to this struct in the C backend, right? I mean, or wait, hold on, or we can just make sure that all of the backends specify this, and then they would be the aliases in the other backends. Yeah, like make it less cursed actually is probably better. So which means that we actually don't have the string and string view types, right? String view, like we actually don't have that. We don't need to type check them. So the type is not string view, right? The type is named string view, so that we can resolve it to the actual definition, whatever it is. Right, but offset or name, and this should be not literal string. We should never have literal string, right? We should instead have string literal function. Maybe I want like string literal as expression. Then too, that would be nice, right? String literal span and name. That would be a little bit shorter. Right, so let's have string literal, which is a string and span. And this returns the expression, right? Which it would be this. Shape is type is name string view, but then we do the compound. Oh wait, no, string. Yeah, string. Yeah, no. We do have the literal string still, and like yeah. Hold on, no. Over here, it is correct. Yeah, because this is before the C happens. That's not when we have the compound literal yet. So maybe we take it back. After all, and just make this. is just in the C backend over here. Calculate literal, right? So this is going to be compound literal, where type is a named string view, and we have these fields, right? Right, but now we don't actually have the string and string view types because those are just named already. Yep. Okay, let's see if this is all that I needed to do. Expected this got /n. We have a Lexer error. What? No. Or yes. Wait, we have the Lexer error, and this actually like panics or something at 78850. Oh wait, no, I understand now. I think this is trying to compile. Where it's trying to compile this to JavaScript. Wait, what? No, what do you mean Lexer error? This is the Lexer error in the bootstrap. Expected this got /n. Yeah, but where? 78850. It doesn't even tell me like the file. Okay, but well, I'm assuming that it is the compiler over here, right? 788. This over here. I'm not sure what's the issue here. I don't see the problem. Well, I mean, what we can try is we can try to do Kast bootstrap lex source mini compiler, right? Yeah, it does lex properly, so I don't know. It's supposed to work. And there you go, now it works. Is this because I saved it right now and it was like unsaved file or something? Maybe. All right, another pattern match is not exhaustive. We need a field over here, right? Yeah, because we actually have the fields now in this example, right? We need the field dot content and dot length, right? So field place expression has the object and the field, right? I think object and field, the place expression and the string. Okay. So we need to give the getter and setter. Get would be the expression, which is, so we need the expression in the CAST, right? Which is going to be the expression, which is a field of object, which is expression, and field, which is string. Okay, so we have a field, object, field, then we print the expression object, we write a dot, and we write field. That's all. So here we say that expression is some field. This should be identifier, by the way. Shouldn't the field names be identifiers too? Now that I think about it. Field should be identifier. Field initializer, field name should also be identifiers. And the yeah, that's the compound literal. Print identifier. To have field, field is this. Object is object, right? Because we need first. Okay. Let's say object is calculate place of the object first. So we over here object is going to be right, it's going to be pure object get. Set value insert statement assigned assignee is, well, I mean, this is the field expression. Is that and over here we just insert statement assign to the field expression the value. When we say compound literal, I want these names to be identifiers. Anything else I changed to be identifier? Let's see. Yeah, this identifier of the field, right? There we go. Maybe it's when I'm like defining the types, the fields should be, but I don't define the types yet in the CASD anyway. Right. Unknown type name string view. Use of undeclared identifier string view, string view. Right, we need to open the compiled C. Here's what I've generated. Yes, I'm not generating the types, that's right. I'm not generating the types at all, and this is the missing part here. Otherwise, I feel like it is almost working, right? I just cannot resolve the types. Right. So which means that in the AST, we need to have the program which has like, so we have includes functions, and we will also have the types, right? And the types is going to be array list of type definition, right? Type definition is right. So we want to have the name, which is going to be identifier, and we want to have the definition, which is type definition shape or whatever, right? I don't know. Alrighty side. What should this be called? Type definition shape or something else? Right, we will have type definition shape, right? Which is going to be we want to be able to specify the struct with fields of field definition, right? We'll have the unions. Union still has the fields, right? How do you define the union in C? Let me see. Should I say type def union? I'm assuming U, and then you have like int A and like boolean B, right? Is that correct? C? Seems like it is. And what about the enums? Do you have type def enum? Unions are gross. What do you propose instead of unions? Unions are a must if you want to have one of the things. Well, I mean, C is gross because it doesn't have the tagged unions, but that's how we represent the tagged unions, by using unions in addition with a tag, right? You have type def u, so like this is like, you know, some data and it's like some tag. So here's what we are going to do. We're going to make all of some types to be represented as 3 types, as union, enum, and struct, right? The struct is going to have the tag and the data, like this, where data is the union and tag is just an enum, you know? It's either A or it's B. Is this the correct struct union that defines no instances in line 42? Struct sum. Right. Yeah. And you initialize it like, you know, sum is tag is A and data is A is 1 to 3, basically, right? I'm assuming this is how you do it. Right? There we go. This seems to work. Is there more type-safe unions, enums? Is enum, like, what is the enum actually in C? Is it always an int? C enum. Can you like change the representation? It's just by default 0, 1, 2, right? It's just auto incrementing. You can like do these things. We don't do the equal though here. I don't think so. In standard C, you must use enum keyword every time you declare a variable. And developers use type def to create a shorter nickname to the type. Whether this is sunny. No enum keyword needed. Right. But the question is, though, I feel like this is going to be a little bit weird, because what happens if you have two enums? Yes, you have the redefinition of the enumerator, right? So you can have multiple structs which share the same name, but you cannot have that for enums, which is annoying. Can you have the namespaced enums in C? Or do I have to prefix everyone with some tag A and some tag B? And this would be like some tag 2A and some tag 2B. Right? Kind of annoying. But okay. What if I say over here some tag 2B? It says that implicit conversion from enumeration type this to a different enumeration type. Right. There's a warning. Okay, that's good. What if I say just one here? And then there is no warning. Okay, this is wrong, but okay. Bum 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 bum. Okay, so abstract, union, and enum. Those are the three type definitions. Right. Well, and also we should have the alias. So enum has variants, which is just a list of identifiers, I suppose. Right. Field definition is having name is identifier and type is a type. And then we also have the alias, which is alias to a type, right? Boom, 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 boom. C assumes you know what you're doing. Yeah, that's bold of them to assume. Does anyone know what they're doing? Also, there's like this issue where you cannot have the recursive types. There's this issue with recursive types, right? Where if you have a struct tree, so you have, okay, we should need to say like type def struct tree, right? Which is going to have a tree left and tree right. And this does not work because we need to first say struct tree, right? Is that right? No. Wait, what do you do? Oh, wait, or do you like say struct tree here? And you say struct tree. Hold on, how do you do this again? Fix available, insert struct. Oh, yeah, you need to say like struct tree, there we go. You don't really need this because you can see it inside, but if you like have the you have like struct tree data, right? And then we have type def struct tree data. You're going to forward declare them. Field has incomplete type, right? And you need to forward declaration. So you need to still say struct tree data in this case, right? No. How is it in an incomplete type here? Am I stupid? How is this incomplete? Didn't you say type def struct tree data? No. How is this incomplete? You can only have the pointer to the incomplete type. Yeah, because like it's not complete. Yeah, it has to be a pointer. You cannot even do this. All right, yeah, that makes sense, I suppose. If it was a pointer, that would be okay. But and if it's a pointer, you don't actually have to forward declare it, right? Yeah. It must know the size when it's parsing the thing. Structure data is the forward. So this is already the different how you forward declare it, basically, right? That's why you have the struct. Yeah. Okay. Got it. Got it. Yeah, that's okay. Which means that we have alias to a type where we have the type definition, but the type itself we should have a struct, right? So this is a forward declaring a struct of type identifier, right? Because that's different in C. Okay. I will not like use the inline struct types, even although you can. We're just going to do this. Okay, so when I print the type, if this is a struct, then we are going to print identifier, and then we just write keyword struct, right? So we'll have to generate it correctly here. So we have types when I print the program, right? So we do the includes first, then we do the types, right? So for type and program types. Right, we're going to print type definition type. All right. We'll print the type definition. Type definition. We're going to write type semicolon / n in the end. We're going to print identifier definition name, right? And over here the actual like definition shape, definition shape. So we're going to match definition here. This can be in line, it's okay. So we have the alias to a type. In this case, I'm just going to print type. If we have this struct with fields, we are going to print, let's write keyword struct. Then we're going to print identifier of the definition name again, right? Then we're going to write the opening curly bracket, increase indentation, decrease indentation, write this. We need to write this space before this identifier too. Okay, and then we iterate over the fields. We need to say print type field type, write a space, and print identifier field name, and then write a semicolon and /n, right? Okay. The union is going to be the same, similar, but for the union we don't actually say union name, we just say union, right? Because we don't forward declare the unions. Or can you forward declare a union? Can you say like union who? Wait, this is correct. So you can. Wait, this doesn't even like complain. Why does this not complain? Because like I don't even know what the foo is. Why does this not complain? Do I say union foo here too? You can have anonymous types. But this is the reference to this now. Now it's not anonymous. Like anonymous if I was to say like union int XYZ here directly, right? That would be the anonymous one. So you forward declare. What about forward declaring an enum? Can you say enum tag enum tag? This one is incomplete. This one also must be behind the pointer. We will only use the forward declarations of the struct though, so it doesn't like really matter for me. The union foo could be optimized out if it's not used anywhere, maybe. Well, isn't the same true about any other type then? Okay, anyway, we're just going to say union, like fields. Well, these are going to be called variants. Or well, I call it fields actually. Whatever. That's okay. We just say union. Okay, and then I have the enum variants. Right, keyword enum. And it's just identifier, right? So we just print identifier variant. And write, and this must be a comma /n instead of a semicolon, right? It must be not empty too, by the way, which is a little weird, but okay. You cannot do a semicolon, right? Expected equal or and. Yeah, we'll have to do the semicolons. We can just do this. It's okay. Okay, now we just need to generate the type definitions, right? So we want we want to make sure that all the types exist there, right? When I'm compiling a program, we're going over just all of the functions, but we also need to define the types, right? So we say for what is my types? Like there is the order of the types too, or is there not? Actually, there is not. Oh, wait. Yeah, the minicast can specify the types in any order, so we need to order them properly then. We need to do the actual top sort here for C. Well, I mean, we don't have to actually. No, forget about it. We don't have to, but we need to do it in a specific order, I suppose. Like, we need to first do the enums, then unions, then structs. And what about the aliases too? When is the alias done? That's a good question. Unless we don't generate the aliases actually, and the aliases would be like resolved already in C. I don't know. Because we don't have the yeah, we just have the set of types which is like ordered. We have the constants which are ordered, but not the types and not the functions. Wait, do we need to do that? Yeah, we do. Wait, so like, okay, so like the unions can be forward declared. Is that right? Hold on, after all, I can have union foo, right? No. Unless it's behind a pointer. Okay. Do I just do them in order where I first specify? So we have the types in general, right? Which are so structs can be defined as last thing. Wait, can they? They actually cannot, right? Because sometimes we want the structs to not be behind a reference. I actually need to do the proper top sort, but we don't need to go behind the top sort if we are like doing a reference. Yeah, I actually need to topologically sort everything, right? Yeah. Let's see. Can you just throw the for declare everything first? I don't think so. Like, because it seems like this is incomplete type. Like, how do I forward declare this? Right? You can only use the forward declaration in a type if it is behind the indirection like a reference, right? Because it's trying to calculate the size of the types. I'm pretty sure this is the forward declaration. So if you select union foo here, this is the same stuff. You don't need to do this actually. Like this is useless because this is already acting as the forward declaration. Same with struct. I'm pretty sure this is unnecessary. So like what we want is have like basically right, I want to have struct we want to have struct A which contains B inside, right? And B is a struct also, right? And then we have type def struct B, which let's say is empty, right? Like this. So this does not work. If I forward declare struct B, it still does not work because it says that this is incomplete type. And it says that it is a forward declaration of B, and I don't need this. Technically, I can use this only if it's behind a pointer. You got your Swizzling code from 10% CPU to 1%. 10 for a YouTube video, 10xing the performance. This one weird trick. Wait, do you mean like your Swizzling code actually has the CPU? I thought. Wait, what? Or do you mean like the CPU of like when you're compiling your Swizzling code? Or what do you mean? Well, I mean, you do compile the things at runtime, or do you not? I don't remember. Or do you mean runtime? Because runtime is on the GPU, and which is not the CPU, no? Yeah, I think we have to sort them here. It's not that difficult to sort things. There's economy in your rendering, so you have to swizzle. I need to make a YouTube video to explain to Goofy Man. Yeah, I do swizzle sometimes too, I suppose. When I'm like doing the texture loading. Actually, no, that's not what we do. We're doing the pre-multiplying of the alphas sometime on the CPU before uploading the textures to the GPU. Wait, can the GPU like do this for me? Why am I doing this on the CPU? I don't know. Or maybe like the image crate that I was using has the option for it. But I remember doing this manually myself. For some reason. Okay, we have name and we have the value, which is the type definition in context program types bitrate, right? Okay, so we want to declare type def name definition. There we go. So type def. So this would like I need like a thing. Has the type been already defined, right? So defined types, right? That would need to be an OR set, I suppose. And we are going to make sure that all of the dependencies are defined before defining the actual type. Defined types is this. It looks beautiful outside. Are you inside of your computer? Computer? You're too lazy to type the com? Or is that like supposed to be the like American accent? Or something. Okay, type definition. Name string definition is type definition. Okay, so first we need to go over all of the dependencies, right? Right. So we're going to match the definition Where's my type definition? There we go. That's what we have. We have opaque. Do we actually have opaque? I feel like we don't need opaques. So enums, they don't have actually any dependencies, right? Enums don't have any dependencies. Unions do have dependencies. Okay. Let's see. We're going to say for we have the type. In variance map. Oh, by the way, I'm doing them in order, like, but yeah. You can see the order kind of matters. It's okay. I don't think it matters for us yet. We might have like bad alignment or something, like bad padding bytes. So I need to like make sure all are defined in the type, right? Like this. Same goes for the fields. And over here, since there's an alias to a type, we need to make sure that all in this type is defined, right? So this is where we go over the dependencies. If this is circular, we need to like probably treat this as already defined. So say context. Yeah, we also say that if context defined types contains the name, then I'm just going to return, I suppose. And we're not going to do anything in this case. Otherwise, we need to like find types. Add the name here. I love my pooter, or my friends are inside it. Right, exactly. So yeah, we're making sure that all of our dependencies are defined, and then we're defining this thing. Right? Which means that when you say context program, context result, types, list, push back, the definition, right? Where the definition is going to be the AST type definition, which is going to have the name, which is identifier name, and the definition, which is the definition. So definition is match definition. Once again, right? So this is going to be AST type definition shape is what I called it. So we have this. Yeah, I feel like opaque is not a thing in minicast though, is it? I don't know what to do with the opaques. We would have to specify what's the type in the native platform for the opaques, I think. So we don't have this in minicast, I think. After all. Right. So this would be an enum. This would be a union, and this would be a struct. Opaque is void star. Yeah, maybe it could be a void star. Actually, you're right. Yeah, maybe this is going to be an alias to pointer to void. I'm not using it yet though anyway, so whatever. And so for enum, we have variants, and this is the list of string, the list of identifiers, right? Yeah. And this over here is an OR set instead. This is what I do because this is like a string. Okay. When we have the union, I actually called it fields here. Convert type, I think, here. Convert type, sure. Sure. Same goes about the struct. So I just need to make sure that all are defined, right? In a type. Right? So we're going to just match the type. Here's all the types that we have. This doesn't need to be here. Ref type, make sure it's always defined in type. I'll list. Make sure all are defined in type. Make sure it's defined in this type. Let's put inner. Unit is nothing. This is nothing. String and string view is also nothing. It's supposed to be in the... Wait, we don't have string and string views. I thought I removed them. Did I not? I'm removing them. And when we have the... Yeah, when we have... yeah, let's see. Native does not do anything. The function... So the name one, this one is the interesting, right? Would say that definition is... current context, program types, app get name option unwrap, because it must be there, right? And then we'll basically type define the name and definition, right? Yeah, so like we'll literally call this recursively here. And it's not going to be defined twice if it already was defined, right? And then we have the function, and the function type is having arguments and result type. So I need to make sure all is defined in the result type, and I need to for arg in args trait. I need to make sure that all is defined in arg type, right? Like this. Okay. Yeah, so we don't have the string anymore. We don't have the string over here anymore either. Yes, so the string is actually going to be defined. So we need to remove this. Yeah, because we will have to define it. Right? Actually, I mean, should I not like specify these things too? Like, why do I have the built-in types at all? Is the question. If I could like have them as all as native types in the a dedicated file. It's because we have the literals of these types. That's why. We still have them as named. It's just like the literals. Yeah, because we still have the string literal, but we don't have the built-in string type. Let's process native type. Oh, right. This is the thing that is known to us. I don't even have... Wait, what? I don't even have that. I need to remove this. We don't even have this anymore. We don't have the native types at all. Type kind native. We don't do this. With chars, you could use something like white chars. Yeah, exactly. That's what we are going to use. Not the first time native were removed. Yeah. This is our land now. I still have a string somewhere. Here. In the types specifically. I don't see it in the types though. String char is not. Yeah, the type is not string. Yes. Why are you trying to oh, the string type? If only my error messages were better. Like it's literally not here though. Oh wait, it's in the IR. It's when I'm importing the IR. So over here we have the string. Wait, what? No, we don't. Oh, we don't. Right? The problem when I'm importing this thing, which means that it's in this file, supposedly. But there is only this string, literal. Save all. Is it not saved for some reason? This was changed since the last compilation, it says. Let's see. Well, it is a different error though now. Indeed. Is my incremental compilation like a little weird? Function type is not args and result type. Wait, what is the function type? Oh, it's not result type. It's literally just called result. Sure. Yeah, I think it did not say that it was. Yeah. It doesn't detect the change in this file. That's a bug in like my detection of what needs to be incrementally compiled, I suppose. Like it still thinks that that's the case, right? Like it did not say that since the last compilation this file has changed. That's the issue. You know? So when you actually like do a change here, it doesn't say that, yeah. Oh, wait, the error is in this file? But I need to change this file. Oh. Wait, why? If I did not change this file, if the error was in that one. Type doesn't have fields. Yeah, in this case, we just have the argument types without the names in the type definition. That's right. Yeah, it's not detecting the file that it was changed. Hello? Or does it? Yeah, and if this is an alias, then we should have the alias to convert type, right? Like this. Oh, it doesn't say that it's detected because this file was not successfully compiled. That's why it's not telling me that. That makes sense, actually. Because it only, like, does the change detection for the successfully compiled things. So result, we need to have the types in this thing, too. In this CAST that we're generating. Okay, it compiles. Is it going to work? That's a question. There is some syntax errors, it seems. Unknown type named type. Wait, what? Oh, it's called type def, not type, right? Didn't see, I'm stupid. Type def. It seems like my just code generation is taking 25 seconds. The type checking is like, I think the type checking is like 4 seconds, yes, on the incremental compilation, but the code gen is 20 seconds. It's okay. For now. Field designator contents does not refer to any field in the type string view. Did you mean content? Oh, wait. Okay. So in the runtime, we actually say that we have the contents instead of content. There we go. String view doesn't have the field content. Contents. This is a lot. Yeah, I know. We can, like, fix things. Okay, anyway, but this works. Look at this. Fibonacci 89. Finally. We have this working. We have the string literals, which are defined as string views right now. Right? So we do that. And string view is a thing with the contents and the length. Maybe it will be fixed. Well, I mean, there are reasons for that. I can fix it even before the minicast from C. Like, I mean, it's slow. The bootstrap is written in OCaml. OCaml is not like it's not slow because it's in OCaml though. That's not the reason. But I can make it faster. But I'm too lazy to work. I don't want to work on OCaml. It makes me angry. We can also define the f right, I suppose. Well, I mean, this is print string. This can be stay native. It's okay. Boom, 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 all right. What is the next example that we should try? We have the Fibonacci and stuff. C strings. Maybe you know what? Maybe we should first though make sure that we can handle like multiple backends properly. After watching the streams, you can see why you want to get rid of a camel. Because Kast is much nicer, right? Right? I mean, I would need to like fix the compilation. The compile OCaml is really nice, and the reason I was writing it is because of the compile times, literally. Because previously I had the problem with compile times in Rust. So, and now we have the problem with compile times in Kast. But that is fixable. I just don't want to spend too much time fixing it right now. Din, din, din. But the problem is that I'm making the mini Kast right now. I'm not making Kast self-hosted, and like that is going to, like, we're already at 14,000 lines of code, right? I feel like it's going to be 30,000 lines of code when we have the fully bootstrapped thing, which means that my compile times are going to be like 2 minutes probably, if not longer, because I think it doesn't even scale linearly but quadratically instead. At least probably. So maybe I will have to drop into a camel and fix this at some point. Their compile times are also getting worse, but that's for something for later me. Yeah, exactly. I don't want to deal with it right now. Okay, maybe we do like hello C, and this over here is going to be, you know, this is going to be like hello JavaScript. How about this? Because this over here we do the console log, this things. Oh, let's keep this a test. But I want to. Okay, let's like make these to be like very, very similar to each other. Actually, oh wait, hold on. Actually, how about we say like hello, right? But then like we're going to have the let's have like another like runtime here. I think maybe, and then we have like C MKS, and then we have the JavaScript MKS, right? I want like the code to be looking the same. After all, in the hello world, right? Like, basically, we want just the Fibonacci here, and like this add sub less. Technically, this is the same in JavaScript and in C, but we are going to have it separate. Copy pasted. Then we want the print string and print int32, right? To be defined differently in C and in JavaScript, right? So in JavaScript, this would just be console log s, because string view is just a string in JavaScript. And it's not console log, actually. Hold on. Hold on. This is not console log. I need something else here. Because we don't want to... Because log does the full line, right? In this case. Okay, and then we do this, and stdioh, so like nothing backend specific should be here, I suppose. So fwrite needs the stdio, and print string needs stdio, right? Which technically we only need to do it once, you know? Which makes me think that I should have this be possible to put anywhere, right? But at the same time, in like when we transpile cast to minicast, we want to only include the things if they are actually used, because that's when we do the tree shaking and stuff, which is why we do it inside of these, I think. Right? Both. And I don't know, maybe minicast could also do some tree shaking. I don't know if we need to, though, because we already do the tree shaking and cast to minicast. So when we see C path, we're going to compile. So this is like the backend, which is like baked into minicast, and this backend, this runtime is like separate, because this is supposed to be like in the standard library, basically. You know, which is supposed to get from Kast. So like, which is like different from actually the minicast runtime, because it's supposed to be generated. Maybe it should not be present in the tests, but it's okay. So we say like we say tests mini runtime CMKS. Right, so we need to like have 3 files now. And if we do the JavaScript path, then we're going to compile target JS, runtime JS MKS. And the JavaScript runtime. Actually, yeah, never mind. We don't need that. Do I have a runtime? Yeah, we still have the backends like JavaScript runtime MKS, right? And runtime JavaScript runtime and this file. And this is target compiled MJS, and then we say node target compiled MJS. And we can have like extra arguments here too. Args, and we put the args here, right? So I could say just JS tests mini hello, right? String view is not found, right? If we say just C, this is working. Okay, let's just make so we just need to say the string view, which is not found. This is going to be in the in the JavaScript runtime, right? This has already been compiling in JavaScript. Yeah, we just need to say the string view. Well, string is the alias to native type string, right? And string view is also just the alias to native string in JavaScript. We might generate the actual like JSDoc type definitions. Maybe it's not a bad idea. Top level string as already defined here. Where? Oh, I just literally say string. String and string view is what we want, right? Because I think I might have broken the thing, right? Because we have unmatched in this pattern matching when we resolve the type aliases. Right, if this is the native type, then this is just the same native type, right? And what else do we do? Maybe there is going to be something else. Let's see. What are you writing your language in, by the way, Hisoka? Just wondering, what are you guys making your languages in? How many people are making languages who are watching right now? Yours is in C++. Pretty much not exhausted over here. Yeah, this is a native. Wait, what do I do here? Short type name, a function. Native. This is supposed to be a string. Native. String escape. A little bit of Rust, Kast, and Haskell all together. You do C++ with direct library calls to LLVMs. You don't need to print LLVM IR, and you can just create object files, right? Is there no CFFI though for LLVM? And you would not have to do C++, I suppose. But maybe you like C++. LLVM, C. But the C API is probably like not as nice as the direct C++ API, I would assume, right? Yeah, maybe. I think there's like a crate in Rust which allows you to like interface with LLVM in a safe manner. Expected native string got native string, of course. That's the problem in the type checker. Because if it's native, then I'm not checking it. Right? We have a native A and we have a native B. Then we should say A. If A is not equal to B, then I'm going to fail. Expected this, got that. Expected this, got that. Can I just say over here, like, fail? And fail. And it's just going to be fail. And we say that fail is this. Or we expected this, got that. Down. C++ with direct library calls to yeah, it is designed to use in C++. Yeah. Printf is not defined. That's right. Okay, so we actually compiled successfully, but obviously we don't have the printf because in the JavaScript runtime, not here in the JavaScript run in the runtime JS over here, right? We have the print int32, which does the printf, and we don't need to do that, right? So we can like start with console log x here, of course, right? This would work. But in this case, we're going to say like this, right? Fibonacci is this, and we do it all on the separate lines, right? So we want this to not be console log. But something else, right? So like, I mean, it depends what kind of JavaScript we're targeting. There are like APIs in the Node.js, but if we want this to be more cross-platform, so it works on the browser, then we cannot use the util log. And util format. I think I'm already using util format. In my like actual runtime. But we can yeah, we can also like append the the thing, you know, we can see, you know, like cast dot print string, and we can like have cast dot print int 32, you know, and we can have like the runtime in like JavaScript, because we can just prepend the JavaScript stuff. We call it JS, right? And we say like that global. Is it global this? Is this always there? Because we don't have the window, right? Necessarily. Or do we have window in the Node.js too? Maybe we have. Window cast is equal to window cast dot. Let's do JS no type check for now. Cast dot print string. Console log can use format args. Yes, but then we can then we must use it all of the line immediately. Is the issue, right? So I need to generate different code. Is the problem? So like this is what my hello world looks like. We need to make all of these to be the single thing then. It is something like this, you know. Something like this is what we can do. I think. And then we can do the JavaScript, which is also going to give me the JavaScript runtime, which is tests mini runtime JS. You know, just a small JavaScript runtime to help us. Window is not defined. Yeah, window is actually not defined, right? Do I say global this? And then it should work, right? There we go. There we go. Now we have the same code. which works with C and the JavaScript backend, right? And it's working. Fix hello world, so it works in both C and JS. All right, what's next? What's next now? Can we do anything with minicast now? Not exactly, right? Because one of the things that we can do in minicast yeah, and we were like trying to make these generics, right? This generic code. Does this still work in JavaScript? Can I say JS tests mini generic MKS? To do native type as identifier. Right. Native type as identifier. Wait, why do we need the something as identifier? I forgot. So this over here is the example of what I'm supposed to transpile my generic code into. And then this is the future example, which is a little more complicated. But this uses the any type. And we did have like the runtime prepared for it in C kind of, if it is actually going to work. To do native type as ident. Okay, why do we need native types as identifiers? I forgot. JavaScript and to do native type as ident. This is just in the intermediate representation when we have the like this, right? Type name as identifier. Oh, that's when I'm generating the type info, right? Yes. Type name as identifier. Yeah. Yeah, how about we just do this here? You know? How about we just do this here? How about we just say output right native underscore, and then we print raw string as identifier as raw string as identifier. Raw string as identifier is like taking string we need to make sure that it works as identifier, right? That's the important part here. So we say that for C in iterate string, we say that if char is alpha is ASCII alpha numeric, or C is equal to underscore, then it's okay. Otherwise, we're just going to replace it with underscore, I guess, right? And then we just say output right to string C, and this should be like okay-ish. Match branch might use the function syntax. Semicolon is unnecessary. Is ASCII alpha it's ASCII. like this is going to be interesting, right? Because this is where we get, so this is the C runtime where we allocate the types on the stack using allocate and stuff. This must be in line though, so it's not going to work immediately. We can start with the malloc here, I suppose, instead of allocate, so that we don't do the inlining. But yes, we have to make sure that the stuff is in line sometimes in minikast. And actually, I was like looking into the allocate. It is not what we want. Maybe we want the variable length arrays instead, because those are scope local, and the allocate is like function. It's like allocating this stuff for the duration of the entire function, which is a little bit less good. Okay, so this is the code, which is, so this is the code in Kast that is supposed to be transpiled into this, where we have the generic code once again, right, which we transpile without monomorphization into this, and this is supposed to work in C2. So let's try to do the C here, but this is not going to say because type info is not found, right? So let's uncomment certain things in this C runtime over here, right? Can I just uncomment everything here? I'm wondering, probably not. It says string is not found. Right, because we have the string view and we have the strings. This is... Can I just say for now that string is literally just equal to the string view though? For now. Extracted one argument, got two arguments. Initialized type info for struct. Extracted one argument, got two. Result. Yeah, because maybe I only did it in the JavaScript, right? We say initialize type info for struct. This is what the type should be. And this is a to do. This is where we need to calculate the member offsets and shit. Right. Right, so the type info in the C gets the members, the stride, and the size, right? And this is where we need to mimic the C behavior, actually. Okay. Can we mimic the C behavior here easily? The rules are supposed to be easy to do, right? We also need to have the alignment. We have stride, size, and alignment, right? Can I just do size t here instead of int? I feel like that's what it should be. Size t is just this. Yep. So we say number literal cannot be offset or name member. Oh, because it's the native one, yeah. Yeah, because it's not no longer an int. That makes sense. Initialize offset or name. Wait, why is this even here? Is this even needed? Probably not, right? Type info doesn't have the kind. Okay, over here. So the type info, we need to calculate the stride, size, and alignment, right? So what is the alignment of a struct in C? It is the maximum alignment of all the fields. Is that right? Is that right? Is this defined somewhere? C struct layout rules. Structure layout. Here are the conventions used on most play. Okay, this is actually very small, small, right? The structures will appear in the structure in the order that it's clear, with the possible the consecutive fields occupy consecutive bytes. However, if at field types demand more alignment, then it would like align it, leaving a gap. That makes sense. Once all the fields have laid out, it's possible to determine the structure's alignment and size. Alignment is the maximum alignment of the field. This structure size is rounded up to the multiple of alignment. We are having a separate size in stride though, which is okay. So the stride needs to be rounded up and the size does not need to be rounded up. So we don't actually need to leave a gap in the end of the structure. Okay, so we just need to understand the alignments of all of the type infos. Initialize type info for struct, right? So we say, so we need the alignment to be equal to 1 by default, right? But then we go over this list. Okay, which means that we need to iterate over the list. Have I iterated over the lists before? I feel like this should be like a built-in thing. Or it should be like iterating over the range that is built in. Or what should it be? I don't know. I don't have any kind of a loop, right? Because in JavaScript, what we do is like, yeah, we literally say like this. We inline this loop here. So do I want this to be something? I mean, it would not hurt, but the problem is that it's like only in the runtime going to be used anyway. And we need a statement, right? Or maybe I do the same stuff, you know? Well, we do have a loop, right? And stuff. We do have a loop, technically. Wait, do we? Or do I have add loop? Yeah, I have an add loop. Which is the infinite loop, which we cannot break out of, I suppose. Well, we can have the breaks, though, technically. And minicast, I suppose. I can implement the break. Do I want to, though? Native. Can I just say for int I is 0, I is less than... Yeah, and what is the list represented in, actually, in C? List should be similar to the string views, right? Where we have like the pointer plus length, technically. Right? So should not these be members dot length? And over here we just do, and this is going to be like statement, which means that we need to do that too for the renderable statement stuff. And over here, we'll have the loop of the body. This is difficult. Maybe I should have the loop after all. It's somewhat built in, right? Maybe we don't need to like make a loop over the list specifically, but like a range loop maybe. Fine, let's have a for I in 0 to members dot length, right? Like this. Is that what I do? Let's implement it. Fine. So we have 4, and this is not going to be a pattern because we will only allow the identifier here. And the iterable is going to be basically start and then dot dot and then end. Yeah, we will only do this. Simple loop. Or should I instead do the while? Or should I have all of them as like built-ins? Like the least amount, the less built-ins we have, the better. Actually. Right? Or should it be iterating over a loop after all? Over the list after all? Decisions. I'm going to get the runtime in JavaScript, right? Yeah, we just do for let of, right? If I don't have it though, maybe I can make it so that the problem is that it is a long line though, right? The problem is that it is a long line. Maybe we can have actually like some simplistic macros or something in minicast instead, where basically what I want to iterate here, right? Native statement for I is 0, I is less than members length I plus plus. Right, I just want something over here to be done, the body, right? I think you know what I think we should be able to do, maybe. Oh, maybe like this is what we can do. Maybe this is what we can do, you know? Maybe I can have a better native expression. So like right now it must be a string, right? But why do we have it to be a string? How about we make a native to consist of the parts, you know? Like this. this already is parsing, right? I would just say this for int I, or we can have like size ti is 0, I is less than. Over here we will still be able to do the stuff, right? So we say this is a statement. So, but basically I want this string to be a multi-line, but then like, why even have it as a string which is multi-line? Oh wait, no, maybe we just do multi-line strings actually instead. So I just introduce the multi-line strings instead of doing this weird syntax. Maybe that would be better. Then it's okay. Yeah, if I can like help, it would be fine. I can implement this relatively easily, right? Let's go to the Lexer string, right? So how about we try to read the string with delimiter? Maybe let's call it let's string impl, right? We're going to say that delimiter is these multi-line is false. You know, we are going to say multi-line is false. We're going to say multi-line is false, but for this last one, we're going to say multi-line is true, and delimiter is going to be this. And delimiter needs to be a string then, right? Like that. Right, so delimiter, which is a string, and multi-line is a boolean. Let's do that and figure out how do we do that. So delim. If c is not equal to delimiter, then none, right? But delimiter, double quotes for single line. Two single quotes for double line, and three quotes. Wait, what? Two single quotes for double line. No, I'm thinking of the Nix syntax, the way Nix is doing it over here. So you have like this, you have multi-line, and it also automatically gets rid of the of this white space. So like this is not part of the string contents actually, so it gets rid of the indentation. I feel like that is nice. Backtick for reverse strings. I already have like template string. Like all of the strings can have interpolations. I don't need backticks there. Right? We use for the interpolation this like backslash and this. So it's already like escape sequence. I don't need to distinguish with a prefix here. Okay, but the delimiter should have like at most two characters, right? I suppose. My reader can only pick two characters in front, and I feel like let's keep that. So which is okay, right? Yeah. Then there's Zig multi-line style also. Let me remember how the Zig does it. Zig multi-line string. Have no escapes and can span across. Yeah, but I do want to have escapes, is the thing. I want to have a multi-line string with escapes. You use the backslash token. Oh wait, you use the backslash on every line. Oh, that's ugly. That is ugly in my opinion. Like I feel like Nix is doing it the best from what I've seen, which is I'm actually not sure. I think the difference between like Nix and like Python with the triple quotes is that the Python does not strip this indentation, right? So if you like have a test pi and you say that def return string, right? Right, yeah. Yeah, this is what I don't like here. Like, this new line matters now, but we want to get rid of that, actually, when parsing it. If you're studying a multi-line string with escapes, now your string here, I'm done with parsing your multi-line string with escapes. All right, let's let me do this. I will say that delim1 is string delim at index 0, and then we have delimiter 1, and then we have delimiter 2, which is if string length of the delimiter is more than 1, then some delimiter at 1. Okay. So if c is not equal to delim1, then return none, right? But also we want to say that if, and the span is not going to be a single char, by the way, then, right? Yeah. If delim2 is some delim2. The string parsing code is the most complex code of the lecture. It's for 350 lines here. And I keep adding to it every time. So we're going to peek, and then we're going to peek 2 over here. So C2 must be equal to delim2 if it is present, right? Otherwise, we say start is reader position, then I'm going to advance for in string iter delim, right? All of the delimiters needs to be advanced basically here. We know the start, and then the open token as okay, it's just delim, and it's not the span single character, right? It is start, and end is reader position, And path is Lexer source path like this then. Okay. All right, and let's also go over here, delim. So this over here, I say that if delim2 is none, then if c is equal to delim, then we break. No, actually, no, hold on. No. We need to like, yeah, we need to break if the next two are these things, right? Zig does multi-line like that, so every line of code is tokenizable. Every line of code is tokenizable. You mean separately, right? But why do you need that is the question. So that you can like easily syntax highlight a part of code, I suppose, right? So that the editor is faster, maybe. Is that the reasoning? I cannot think of another reasoning, but like even if that's the reasoning, it's meh. Just so that the Lexer is simpler. Yeah, I guess. I don't think that simplicity of the Lexer is important though. I don't understand this like obsession with simplicity. I want the things that are easy to use, not simplicity of the implementation of the tool that I'm using. Doesn't matter. And you want to parallelize that Lexer in theory, but is it the Lexer even the bottleneck that you would need to like parallelize? You can also already like Lex multiple files in parallel, I suppose, right? So and that should be like more than enough. Like this is like this. It's not even a micro optimization. It's like the nano optimization. I don't get it. Well, unless you're writing huge files with billions of lines or something. It's for the LSP. But the Zig author doesn't even like LSPs anyway, as far as I understand. So why is he thinking about this? But and even then, I don't think it matters for the LSP either. I don't think it matters for the LSP. Much. I mean, it does, but I feel like there could be a different implementation. But yeah, it does make the implementation simpler. I agree with that. And just that it's, yeah. Even in the LSP, I feel like it's going to be the parsing still. Or like the LSP needs not only to Lex, right? And so so the Lexing being like highly optimized like this doesn't even matter much. Because you would still need to. Well, I mean, right now what I'm doing is that I'm like lexing in my LSP the entire file from scratch, of course, right? And then I'm parsing it all from scratch and stuff, and all the things. So, but you would be able to, if you just know the changes in the tokens, you would be able to like modify your parsed syntax tree a little bit so that it's faster, right? But similarly to how you modify the syntax tree when the tokens were changed, it's the same when the characters have been changed. So you can modify the tokens, if you know what I mean. So like you don't make every expression to be a single line to make the parser simpler, right? All right, anyway. I have this next to R. Oh wait, I do have next to R, and that's like part of the reader actually. Okay, yeah. You know what? How about we then do this? How about we do this? Um is next the delimiter basically, right? Which is a string, right? Or let's have the delimiter. How about this? We have the delimiter as a type. Delimiter is a type. Where we have the C, which is char, and we have C2, which is optional char. So that it's not actually a string. Right? New delim from the string is what we are going to do, though. Right? It's going to return the delim. Let's say that C is string add 0, right? And then string length is equal to is more than 1, and C2, this is going to be some string at 1, else none. Return CC2. Yeah, so the delimiter is actually delimiter. This next delimiter, which is delimiter. And context reader is Lexer reader. Context Lexer reader, right? Yeah, so basically we say that if delimiter C2 is some C2, then we want next to R return next to R delim C C2. So C1. Else reader next is delim C1. Okay. Let's have a helper like this. Is next delimiter, right? So over here, we don't do this code then now. Right? Yeah, we just say that. And we don't do this, right? Yeah, we say like hold on. If next is delimiter. If next is delimiter. If not, then we are going to return none. So we have not read the string. We cannot start reading the string here. Otherwise, over here, how about we do this? Open token is it's like consume delimiter. How about this? So consume delimiter is going to give me the token, which is the delimiter, right? Consume delimiter. And this gives me the token. Which we also can like check if hmm. It's probably better to check it here though. So say that if not, next is the limiter. Then we're going to just like say that we expected string delimiter. It's difficult, right? Where's my ending? Reader advanced reader, right? Yeah, this is the close token. Yeah, we just say unfinished string here, right? So close token is just consume delimiter again here. And that's all that we need to do here. And we don't need to advance the reader then anymore. Wait, what is this? Start and is like over here. That makes no sense. Oh no, this is like the actual start. Okay, got it. I think this is like that is what we want. Yeah. This is just me figure out like the raw string. Okay. Next is delimiter. If not, next is delimiter. Then I want error with span unfinished. Yeah, we have unfinished string of this entire thing. Actually, maybe I don't check it here. Okay. Assumes we already checked that next is delim. Yeah, how about this? Right, because we have the consume delim over here in the open token, but over here we actually checked it, right? And this final for the closed token we need to check, right? So if not, next is delim, then we are going to what was here previously? And like, yeah, so we didn't spend so far. We need this thing, right? So spend so far is start, and then the current reader position, and then we just do error with span, spend so far, unfinished string, right? Because we expected the thing or whatever, right? Yeah. Okay, so delimiter of here is equal to new delimiter. Like that, right? Let's do this multi-line. Like that. Okay, so this is the 3 types of strings now. And this is the multi-line true. And this is not C is the limiter, right? This if next is the limiter, delimiter, then we break instead, right? Yeah. And if slash n only breaks if we like not multi-line, and this is a new line, then we also break. Okay. So this doesn't like strip. I think this should work, but it would not be stripping the white space in the beginning of the multi-line strings, which technically I don't really need right now, I suppose. If string length is more than 2, then panic. Most 2 chart delimiter, please. Can find start. Yeah. So start is reader position. Right. What? Delim multiline boolean. No delim. What do you mean? Am I stupid? Typo? Did I say multi-line? Oh, I did say multi-line. Okay. In the definition over here, multi-line. Yeah. Yeah, the error message should like point me at the specific field, probably, that I see it. But yeah. String is not delimiter. All right. Yeah, so we don't say delim 1, delim 2 here. This is unnecessary because that's extracted into a helper. Start is not in scope. Yeah, we need to know the start though before I consume the starting delimiter, right? So start is just reader position. Okay. What else? Could not find read string with delimiter in scope. Right, because this read string implementation, this is for the raw identifiers. We actually want read string implementation where the limiter is, well, it means that I need to make this after all, right? To be here so that I can. Well, should I be using like any string? Wait, shouldn't this be just a read string? This should be just read string, right? Let's just do read string. There we go. Unwrap. I don't need anything. Okay. I think it's going to compile now. Okay, so we should be able to have multi-line strings if I did not make a bug here, which we are not going to strip the white space from, but it doesn't really matter much. It's okay for when we generate the C code. But then I will add the thing to later to strip the white space. I'm just lazy to do it immediately. Let's see, echo. No, not echo. I have like test, ks. This, right? I say cast flex, tests, hello. So if I say like over here, the multi-line string like this, there we go. Right? No, it doesn't work. Right. Oh wait, I see now. I see now why. it does make sense. It's because we have the priority actually. Right? We say that we are first trying to read the string which starts with a single quote, but we should first try the one which is the double single quotes, right? There we go. Okay, now we need to recompile everything from scratch. Or do we work on the strings to strip the contents immediately? There you go. So we have this, and the contents is that, right? But we want the contents of this to be just hello world. Is the idea, right? Wait, does it mean that I need to strip the trailing things too? Like, right? If you have a multi-line string, should it end in the new line or should it not end in the new line? I'm actually wondering what's the rules of Nix multi-line string. I feel like I don't want the trailing new line in this case. I literally just want to trim and also remove the indentation. But we still want to allow the indentation, you know? Like we want to say like, we want to basically have the code embedded in this line, right? Like, def foo pass, right? And we want this indentation to be stripped and only one indentation to be stripped here, right? So how do we do that? Can I just change the token here? No. We have parts. Oh wait, and we have like the interpolation too. It's like not that easy. I cannot just like post-process the contents here because we have interpolations inside, right? Because we can have this, and we can just like return, and over here we have the embedded like 2 plus 2, for example. Wait, what? No Kast implementation found? Wait, what? No Kast implementation found as... Oh, am I trying to print the delimiter? Yeah, because I expected the delimiter, right? Or something. Yeah, to string delimiter. That doesn't work. That should be delim.raw. Okay, that's a bug. Okay. I think we just have the... What do I do? I mean, we can also make sure that when we have the new line, like that we don't, like even in multi-line, we can have the string to have multiple parts, right? Kind of. I don't like that too much. I mean, they only need to combine it. I mean, we can for now just have the indentation of the first thing. Basically, we see the first character, right? And that's when we determine the indentation, right? It would just not work. Actually, I'm wondering if this would work in Nix, where like you have the indentation like over here, but then you get rid of the indentation, right? I feel like this would get rid of like this indentation in the beginning in Nix. Do we want that? For some reason, maybe that could be fixed later. And for now, we do the simple stuff. Right? And we will return the error if there is a line which starts with like not the same white space as like the first thing. Right? Right. Maybe this should not be like, it's not just the multi-line, right? It's also, like strip indentation. Like it's a very specific thing. Maybe we want to have the multi-line like rostering with all of the stuff, So here we say strip indentation is true, but for this we say false. Okay. So we need to skip all the white space first if we do strip indentation, right? Yes. So how about this? We just say if strip indentation, then we just say while a reader peak reader is sub C, right? Say a reader advanced. We will say that indentation is this. If we don't strip, then the indentation is just empty string, I suppose, right? Otherwise, we say mut indentation is empty string. We also say that if character is equal to the new line, then we restart calculating the indentation, right? Indentation is empty, right? And if it's not the new line, then we add this character to the indentation. Indentation plus equal to string S to string C. If it is white space, right? So if char is ASCII white space, right? Or do we just use support the spaces? It's okay. Let's support all of the top character too for some reason. And if it's not ASCII white space, it's not the /n, right? Then we just break up to this loop. Otherwise, we have added it. We advance. Now we know the indentation. And whenever we see the new line, we say that if new line, then we do something like this. If it's not multi-line, then we are going to break out of reading the string. And if otherwise, we want to basically skip the indentation here after the new line always, right? Let's say if strip indentation. If strip indentation, then we want to basically say that that like for expected in we are going to iterate over the indentation string, and we are going to expect every character to be present here, right? There's like one exception, right, where we say that if next is the limiter, then we also break out of this loop here, right? But otherwise, we expect this character to be present, right? So if next, if not, reader next is expected, right? Then we're going to error at current position. Wrong, like expected more indentation in multi-line string or something, right? Is that good error message? Okay. And otherwise we just reader advance here, right? Does this look correct? Let's try. Well, something is not correct. Something is ASCII white space is not there. Do I not have his ASCII white space? Wait, what? Or do I have just his white space? Is that what I call it? Bootstrap. Char. It's just called this white space. Okay. Sure. Oh wait, but what if it's an empty line also? If it's an empty line, then we just like, what do we do for the empty lines? That's a good question in the multi-line string. And to reborrow this, right? Because right, so if we have an empty line here, and over here I like call the function foo, right? What should this line be? Should this be just literally empty line in this case, right? Maybe it should be, right? So we say also that if reader if reader next is a new line, then we also break, right? Because like while we're reading the indentation, actually, like if the entire line is new, is like empty, but we expect to not write the def there anyway, right? Do we? Yeah, maybe. I just break out of this loop. Oh, wait, but I need to advance. Hold on. Right. Okay, so like we always need to advance here, right? Reader advance over this like new line character, and I need to add it to the string, right? And to add char. And to add char C, basically, which is the /n, right? Advance. And over here we need to like also continue this loop of the reading, technically, right? So we are technically going to add some some white space if this contains like white space characters, this line, then we're going to add like this to the content, which maybe is okay. We just wanted this, right? Maybe. I'm not sure. This is complicated rules actually. Okay, so there you go, right? This is not right because the contents is foo/n/n. Wait, what? That is not even right. Oh no, it's interpolated, right? Okay, hold on. We have interpolated, and this is the parts, right? So this is the interpolated part, and this is the not interpolated part. We only care about the contents here. This probably should not be printed like that, but you know, whatever. So we say like, so we start with def foo/n, and then just 4 spaces, and then return, right? So this has been done properly. And then after the return, after this, we also continue with /n/n. So this is like the empty line, and then foo without any indentation. All right, I think this is correct actually. For what we want, we can restart Kast language server, so it is actually going to highlight this. Once it starts, there we go. Wait a second, why does it not syntax highlight this to be a string? Oh, wait, I think I know why. It's because the semantic tokens don't actually support the multi-line tokens. Is that specified in the LSP spec? LSP spec. I'm using semantic tokens here for the syntax highlighting. Let's look at a concrete example which uses single line tokens. Wait, this implies that we can have multi-line tokens though, right? Why do I not have them? I also need to change the text made grammar, I suppose, so that it works properly. I think. Let me just commit this. Lexer multi-line strings. And this is like the other things that I was doing. Maybe let's focus on the other things first that I were doing, right? I was trying to like write the raw thing over here, raw C code, right? We want like for int I, for size t, I is equal to 0, I is less than members dot length, right? I plus plus, right? So now we have this multi-line string, and we can like embed the expressions here, and it's like readable and stuff. Which we probably need to like, because the C is not going to work yet. We should do this in this first, right? So we're going to have this statement, you know, like this. We're going to have statement for that member of this, and over here we can do like that, right? Which makes it a little bit easier and not like a single long line to read, right? I think in the JavaScript though, I think I like strip prefix, which is like statement colon space, right? Yeah, over here. But I don't want this space in this case, I suppose. Right, we just do this. At the same time, like I should be able to just get rid of the spaces in my native expressions in general, right? To have a string trim, right? Yeah, we just do string trim s instead if it starts with a statement. Let's trim here too, why not? Actually, you see, like this over here is green. And the reason for this being green is because this is part of the string. So I actually introduced the semantic token here, which is a string. So it does the synthesizer here, but not for the beginning of the line. Because this over here is generating the multi-line token. So I can fix that. And also because like this is a multi-line string, it thinks that these parentheses are trying to like match and stuff. Yeah, I would like to fix it here. Let's just say just JS like this, right? So we still have the same code. Here's my generated JavaScript though, which we should be able to see like for let, right? Wait, what? This is what we have. This actually seems like it's not correct. It's oh, because I'm trimming the raw part. Oh, I see. Because I'm trimming it like, yeah, because it's the part, right? Yeah. This is the, I don't need trimming here, actually. That's not correct. But I want to like trim it if it's the first one, maybe. And I want to trim the start of it then, in this case. Maybe like in this specific case, so that we keep the space. Do we have the trim start? No, we don't have trim start. I mean, I can have it, but eh. Fine, let's do this. Let mat as start is 0 while start is less than string length s. and string at at start. Char is white space. How about this? Then we do start plus equal char string encoding length. The string at as start. Like that. And then we say like substring from the start. Okay. Maybe that would be like a better. Right, here's my compiled JavaScript again, right? It did like get rid of the new lines though. I do have the spaces, but where's my new lines? Over here, wait, hold on. Over here, I do have it. Over here, I do have it. And over here, I don't. Is there another 4 maybe in my runtime? Is it, oh yeah, it's also over here. That's right. Also, this can be like simplified too, right? Let's simplify all of these things. So I'm having the object where we have the get, which is returning object get. Like this, and set is value into object get this is equal to value, and this is the object that I'm creating. I think also I'm not I'm not trimming the final stuff right now, right? It does end with a new line though. That's okay. Actually, maybe we want to end it with a new line. If we don't, then we do this, right? Yeah. Maybe actually, and in this case, maybe we actually don't, and we do actually this. Right? So we have this getter setter, and then we have this statement. For that member of this, do that. Like this. Yep. Okay, so this still works. Okay, this looks nice. Kind of. The other like stuff in this code we'll fix later. Yeah, but we don't have like this. Yeah. Okay, no. Yeah, I like this. I think this is fine. All right, and then we wanted to do just C. Generic, unable to infer the type over here. Alignment is equal to 1, right? So this over here, we want to say that this is size T, right? We want this to be size T. And then I think over here we say this I++ from these two members length. We want to say we want to calculate the maximum alignment, right? Member info has the type, right? Right. So we and we also want to like this is a list which we will need to mutate. Type info has the members, right? Yeah. We want to say T members. Well, it says T details members. No, we don't have the details. Why do we have the details in JavaScript? I don't know. I don't remember anymore. We just want to say that team members is members. We want to set the alignment. Let's just say that T alignment, we start this between 1 and then we like going to mutate it, right? And then T size equal to 0. And then the members, right? Like that. But we will want to change the, calculate the offsets and, oh, and we also want to say the stride, right? Yeah, but the stride is just like round up. We want to div round up T size. We want to divide this by T alignment in the end, and then multiply this by alignment again, right? We don't have the operators. Multiply this by T alignment, right? Which means that we want to specify the mul here. Right, which is going to be A. And in this case, we're doing the size T specifically. Size T, let's return size T. This is just going to be a native A times B. And then we have the div round up AB, which is when we divide by B, but before dividing, we say A plus B minus 1. Like this. A plus B minus 1 divided by B. And yeah, and this is like non-negative, so that should work. All right, so we multiply div round up, and over here we calculate the alignment, right? Let's first say that so like the member type is members. I think I use this syntax. Oh wait, and this is native code. Hold on. I cannot refer to this variable in the interpolation. Actually. Yeah, I feel like we want somehow to also make it possible to refer to the variables in their raw parts. Otherwise, this is like not treated as cast. Like unless we would like write the raw C code here, right? Where we say that so we will have like type info member type, right? Which is going to be the so there's going to be members data at index I, right? But then how do I access the T alignment? I mean, we can access T alignment like this. Do you actually have the maximum in C? Or is it in C map? Can I say that if member type alignment is more than T alignment, then T alignment is equal to member type alignment. Something like this is what we do. So this is me just calculating the alignment. I also need to add up the size. I need to figure out the padding before this member though, right? Which we know the current size. Because over here we need to like round up. But I want to round up basically like on this. I want to like actually like yeah. Like what should be like the mechanism of me referring to the C variable inside of this like native stuff, right? Because I can refer to the cast expression by doing the string interpolation like this, right? Should we like interpolate inside? Should we be able to interpolate like inside of the interpolation or something, and that would like do the raw code? Oh wait, no, wait, no, we actually can. I just realized we actually can. It's called native. Native is like the interpolation, which is like putting the raw code there, right? Okay. Which means that like over here, I want this to actually be the, I want this entire block to be interpolated, if you know what I mean. Alright, I'll have to end soon though. The native right, native C are that was such a hack. I love it. I don't know if I know how other languages do this, but I mean other languages like it only makes sense if you transpile that, right? But I mean we eventually will not have the transpiler, but the actual compiler. In which case, so like the native expression is like has the meaning which depended on the target, I guess. And then when we do the LLVM, this could contain some LLVM native like some LLVM specific instructions to the compiler, you know. So that's what it means, right? I don't know how other languages do that. I mean, usually the languages only target a single target, right? And I'm trying to like target multiple targets at the same time. Which is why we have it, I suppose. So we like interpolate the full like expression here, which I'm going to put here, the expression. And we do like the semicolon after the expression because it's a statement, but it doesn't really matter. Okay, so over here we can write like the normal cast code, right? We can say that let. It's a little weird, but okay. Let member type be reference to the it's going to be reference to members dot. So members is a list, right? And we can just like yeah, and we can index into the list at index. And so over here the index is the raw, right? I cannot just say I because I is not present in the current scope, but we can say native I, right? And that is going to work because we do have the I in scope here. Is this not the syntax that I'm using? Hold on. For the indexing. I thought that's what I was using. Index. Yeah, it's the dot. Oh, but this should be having the any. This should have any because it's inside a parenthesis, so we can parse anything there. That was missing. So I think this should work. So the member type, this is a reference to a member info then. This is going to be inferred. No, this does not work. I think, yeah, I need to recompile actually now for the LSP to pick it up. Let's recompile. And I have to actually recompile, I think, because we don't detect the dependencies on the files that we read at compile time. Okay, so yeah, we just write this code, right? So we say if member if greater member type dot alignment, right? If this is greater than t alignment, then we're going to say that t alignment is equal to member type alignment, right? So we need to have another function which is called greater, which works for size t's like this. Okay. What else? So we need to do the size, right? So we need to calculate the padding before, which means that we just need to div round up, and we need to like multiply div round up the current the size needs to be rounded up by the member alignment, right? And then we need to multiply it by the member alignment, which I guess maybe we could have like the function that's called like align, right? You know, align align x size t with alignment, which is size t, and it returns size t, which literally just div round up x, we divide by alignment, and then we multiply this by alignment, right? Right. So t stride is we just align t size with the t alignment, right? But then we say that member type offset or name is equal. So offset or name is the size t, right? Yeah. So this is going to be equal to align t, the current t size, basically, like all the previous fields, is going to be the size of the thing, and we align by the member type alignment like this, right? And then we want to say that, and then we want to increase the size too, right? So we say that t size is equal to basically the member type offset. We need to add to this size of the type, right? So which is the member type member type size. Well, this should be just member, right? This should be like member type alignment, right? Member type. This is member offset, but member type should just be member dot type dot alignment, and this is just member, right? Yeah, because this is a reference to the typing form. I think this looks correct, right? So we align every field and calculate the size after each field, and then align this struct stride to. Yeah, see, this is parsed properly. Okay, but number literal cannot be type size t, right? Yes. Let's just say over here native native 1, right? Because size t is a native type, we don't know like how to convert it. So let's just like embed the code here for this. Hyperland, yes, I am using Hyperland. Doesn't have the E in the name though, right? And then we have the list member info doesn't have the fields but this is not implemented yet. Okay, but we are getting closer. All right, I'm going to end here though because I need to end, and we are going to continue the progress next time. I think you can talk in Russian, Darova. Lionheart. Могу. Ну могу. Yes. Okay. What was I just doing? Like, how do we describe this? I don't know. Progress. Okay, this is not the best commit message, but that's okay. Lionheart is asking if there is the reason to find the job in IT. I don't know. I have no idea. I have no idea how the job markets work. As you can see, I'm streaming, not working. Right? Can you also speak in Lua? What's the best Lua code? A vim.opt.gui font is right. Check is live. Yeah. I mean, there's a bunch of people who are live. Let's see. I don't know. I'm not like a fan of the vibe coding though that Borrow Checker is doing. Is the issue. A little bit. I'm not a big fan of vibe coding. Also, the screen is just censored here right now. We're gonna go look at some Rust instead, for example.
Okay, so maybe what we do is we do this.
Call him. Who? Borrow Checker? No, I'm going to end the stream. How about that instead? How about we end the stream instead? Alright, see you guys next time. Thank you for watching. Bye.
Hiding player one's. Oh, hiding player one's move. We don't actually.